and I have some really cool toys to play with today. So for everyone who's here, and I'll just check if you're here, definitely give us a shout out in the chat. You can see my OBS and YouTube laptop back there is working real hard. It's got the fans going like it's a jet ready to take off from Long Beach Airport, which is basically right next to that. So first of all, thank you for joining me. This is going to be interesting and fun. And yeah, definitely engage, ask questions. I will check like as regularly as I can remember to check the chat and the comments, and yeah, we'll see what happens. First of all, when I, before I dive right into the technical stuff and bringing up these boards, I just want to point out a couple of things that have helped bring this together. First of all, the boards that we made, and this is, if you've read the blogs, you'd see this. The boards that we made are based on an NXP IMX8M Mini EVK. And I chose that because it was a perfect balance of the capabilities of Quilter last year as a placer and router tool, and chip features and capabilities for being able to demonstrate what we wanted to demonstrate. So the important thing there was have a system on chip design that was fast enough to do some basic video processing, or perhaps even join a Google Meet, and we've actually achieved that goal. And simple enough that Quilter's AI auto router in 2025 was actually going to be able to place and route the board. We're really pushing this, and we use this to push our technology and to push our model and train the model more and more, because one of the important things about Quilter is our technology and our model is based mainly on reinforcement learning. But what that means is we also are dealing with routing and placement as a service, you could say. And so our promise to commercial customers is we're not training our generic model on your data unless you open that up. And that's obviously a concern for many people. So we have a lot of work internally, and it's partly my job as the staff electrical engineer to drive and help train that model. And to do that, we're using known good real world designs that are not just open and free to be used, but actually things that can be built and actually work. And so this was proof of that. Having based it on the IMX8M Mini EVK, there's a lot of similarities. Basically, it's essentially the same board design, like the same shape, the same connector placement. And what I'll be doing today is leveraging that to do the bring up work, because it's important. Like, we didn't know if the blue smoke was going to come out or not. So we wanted our system on module board to be the same connector placement and orientation and so on, so we could plug it into an original NXP board and vice versa. And so I'll be doing that as we go through. So welcome, thank you for joining me. And well, the other thing I wanted to quickly mention, we did partner with Sierra Circuits. It was a commercial thing. Like, we paid for the boards to get done. We didn't ask for any favors from them, but we also knew that we were pushing the limits, especially on the system on module, and I'll get into some of that as we go too. Because to really push that envelope, we did want to reduce the trace width and spacing to where Quilter could get close to 100%, and I was only needing to spend time tidying up power delivery network and polygons and some of the length tuning and things like that. So so thank you to Sierra for being domestic, allowed us to work closely with them, and thank you to them for really pushing the envelope and helping us do a design that would normally be considered on the verge of HDI, but almost, but not quite. And lastly, I wanted to mention a big shout out to Daniel Bogdanov. Hopefully he's in the chat today. Thank you, Daniel. Daniel's been an industry friend of mine for a while, and he helped me out with this beautiful Rohde & Schwarz MX-05. It is kind of, it's on loan, so I will send it back to them, but it's a serious instrument. It's way better bandwidth than the instruments I personally own, so it's going to help see more detail as we look at things today with this bring up. So thank you to Daniel and Rohde & Schwarz for lending me this beautiful piece of gear. It really is a wonderful and easy to use machine, actually. So with that, let's dive in. So first of all, I've got to get my stream controller should be working here. I'm not sure why it's not, but let's just switch to the near camera. So this is an existing known working speedrun computer, and you'll see what I've got here just for fun and interest and learning how to use this beautiful scope before me. A near field probe around one of the chips. And so what we're actually looking at there this is March 25th. Oh, no, we're good. Yep. So what we're actually looking at here, this board's actually up and running. It is running a Linux build, and a lot of the bring up actually involves tinkering around in a terminal with Linux, because a lot of the tests are actually done using tools that are provided in the NXP board support package for this chip. So what we're looking at here is an existing working speedrun computer. This is a baseboard and a SOM board that were routed and designed with Quilter. And so this one being known good, I know I can bring up the other one with the same image, but we'll actually go through as if we're essentially starting from scratch. Oh, I do not know why my stream controller is not working, so I'm just going to have to manually click things, or I'll just restart the software. Let's try that. VST, come on. Perhaps I should have got the Elgato Stream Deck instead. Maybe it's more reliable. Okay, now it's working after restarting the software. Phew. Okay. So this is roughly the setup is going to be. Now, one of the other things I'll point out real quick, I'm going to bring up, let's see if I bring up the design. I'm just separately opening a browser tab to get the design in the Altium workspace here, so I can share that screen as well. It's just faster while I'm running OBS Studio on my laptop. I could run Altium at the same time, but it's probably going to be a lot faster to use the web browser to show you the design. So let me just switch to see, there's my scope, there's that one. There's the board close up. Oh yeah, that's the other browser window I have for connecting to the MXO. This is the other cool thing about this one is let's connect to the oscilloscope over a web browser session. Uh, Full screen mode. Let's refresh. This should be, yeah, there it is. Okay, back to full screen mode. Expand that. So the nice thing about this is I can directly share you the scope screen as well, of course. Let's trigger off. Trigger off. That's the near field probe around the eMMC flash chip, which also has a crystal oscillator there, which I believe is probably that primary component of the harmonic there. Sorry, the fundamental there that you're seeing that spike, which is, I think it's around 280 megahertz or something. We'll get back to that. Anyway, so that's working. I've got my terminal window, which needs to be reconnected to the board, but that doesn't matter just yet because, first of all, let's talk about the design. And let's just go to my main laptop screen here so you guys can see that. So these are the original but imported and then cleaned up OBS, IMX8M Mini schematics. And all these design files that we actually use, the before and after, like the Altium files and the Quilter results, if you go to the quilter.ai website and read the blog on Project Speedrun, you can actually download these and look at them for yourself if you have an Altium designer or an Altium designer viewer to use. But this is Quilter. Candidate number 88 was the one I ended up going with, as it was the closest completion, plus it also had, to my mind, as I was examining different ones that got to closer completion rates like 98, 99%, this was the one that, to my mind, had the least work required to get it ready for production. So this board went down to 3.5mm track and space, so it was able to be done without any special advanced processing. And if we zoom in, there were a few things that were issues with this design. Namely, the revision that I was able to download and then modify and then run through Quilter from the NXP website was actually an older revision of hardware than what is currently being manufactured and sold for the EVK. So there were a few differences, and some of them were issues around component availability, for example. It's the same old story, right? So for example, these push button switches, and you'll notice that in this one, there's some air wires there. That's because there was, I had to replace these little push buttons with an equivalent by C&K. And the C&K data sheet at the time did not give a schematic or table view of which pin on the surface mount switch was going to which switch contact. And so I had to make a guess, and of course I guessed wrong. And so those footprints were updated, and what that meant was we had the actual switch closure contact going straight to ground and not going to the actual reset or power on off, soft on off line. You'll also see I didn't clean up that tiny little acid trap right there. Somehow that did not show up in DFM. Sierra didn't seem to care about it. I think it was just a big enough gap that they're like, it'll be all right. Or maybe they just added some copper into that and left it as is. But what that basically meant was on power up, I got nothing from this board because from the factory with these switches fitted, it was essentially shorting out the on off and the reset hard to ground. So you'll see that when I bring the last board out. Okay. Let's go back then in that case to this. So it's again essentially the same layout of the connectors and the module placement, the connectors, the dip switches, all of that was fixed in Quilter. Oh, the other footprints that I had to make a change to were these USB Type-C connectors. The Type-C connectors on the existing design went out of availability, so I had to replace them with these ones. And that meant doing some minor changes after. This was discovered after this candidate board had been done. And so I did have to make some cleanup changes because those footprints were not the exact same as the USB-C connectors that were on the original design. So that's the baseboard. Let me show you. Excuse me, I'm just still getting over a dry cough. It's been lingering. Okay, now let's look at the SOM. Now with the SOM board, it should, let's see, somewhere else. There were a few different ones. So what we wanted to do, at first I was trying with the IMX93 EVK, but it became apparent that we were never going to get the video processing capability we wanted to be able to join, say, Google Meet or whatever with the IMX93. The IMX93 does have good video processing capability, but it's really more targeted towards object detection and edge inference. And it's not like full-on GPU where we could have 3D and 2D acceleration like we can with the IMX8M Mini. So we tried a couple of different things. We did a variant with VIA in pad. And also another issue that I ran into early on was all of these EVKs tend to use Wi-Fi modules that are on the SOM board. And those Wi-Fi Bluetooth modules are typically available in the market at the time this goes to production, and then we're a few years later now, none of those modules are available in the supply chain. So I just removed it completely from the SOM design. Now, what I'm looking at here is this no Wi-Fi BT variant. And this is as unmodified, but you'll see I've taken this same project in Altium, so the same set of schematics, rules, set up everything, but I've made various duplicates of the SOM board for setting them up in different ways and submitting them to Quilter experimentally over the course of the year last year. The actual candidate that ended up being the one we went with and went to production with is this IMX898 7 Rev 821. So this was actually, I want to say this was produced, you can see we weren't using the rooms at that time. That's why they're way down there in the corner. This was done on a dev build of Quilter. So at the time it was very advanced and experimental. It hadn't been released to the public or available build for customers. Nevertheless, this was the one that produced the best result at the time. And as soon as it was ready, we wanted to start pushing this and see if we could get something to production. So this has been added to this design. And again, you can download these files from the Speedrun blog post as a zip if you want to look at them more deeply yourself. One thing we did do is we extended the board edge just a little bit to give a little bit more, maybe another 100 mils or 1/8 of an inch or so routing room on the top of the board, just to push that completion from 98 to 99% or 99.5 or whatever it was. The other thing was we did pre-place all the components on this board. We didn't do the Quilter automated placement for the SOM. Firstly, because it was in a very much a state of flux at the time. And there were certain things that are now released which would enable it to do this kind of thing much more easily, way more easily, in fact. Like at the time, we didn't support rooms. I just mentioned that, or any other kind of floor planning. We have a lot of that now. So, I should probably run this again. And indeed, we do use these boards internally for testing in an ongoing way. But that's just to be completely transparent and upfront. And the other thing was we had released length tuning. So if I go into layers and let's look at top only. Now you'll see two different sort of length tuning patterns. And the reason for that is we did introduce length tuning, and Quilter did length tune the DDR4 routing on this board. And it did it with this kind of seesaw pattern that you see around here, right? And so a lot of the DDR length trace, like data bits and address lines were tuned that way on the different layers. But one thing that we hadn't released at the time was the physical analysis of via structures to be able to include via delays. Excuse me. So essentially, I had to go in and add the via delays post routing and then retune these to take that into consideration. And yes, to get these tuned, they're very close. They're very fine traces, fine trace and space, and there's a lot of closeness there. And I was very much relying on the knowledge that good DDR interfaces on modern SOCs do link training on boot up, and I'm relying on that and the equalization that's done on the interface for it to be robust and reliable. Turns out we've done 9 out of 10 boards bring up now, and they work. So so enough with the waffling and explaining of the actual design. I'll leave that to you to examine more at your leisure, but you can see we use unbroken ground planes, inner layers. So we try to architect things for high speed and impedance control design and routing as much as possible as microstrip lines. And then we have some offset embedded strip lines. And again, these were all maintained to within 10% or so of the 50 ohms for the single-ended. I think 90 ohms for differential for the clock and DQS. You can see those were all routed by Quilter as differential pairs. And again, some of those, like this one here, this diff pair length tuning, this segment of length tuning was actually done by Quilter, not me. I went in and added some others later because of, again, via delays and that sort of thing. But so that's just some insight into the actual routing of the design as done by Quilter. So let's go back to the bench here. So we've got the scope. we've got our board close-up. So this is a working board. And so the basic process I'm going to go through here is I'll disconnect all of this. We'll start doing that right now, and I'll get the NXP original, and then we'll get the 9th board from Quilter. Sorry, the 10th board from Quilter, and get that going. So I'll just power this off. So just a bit of explanation here. We have this micro USB. That's for debug for the FTDI chip. That the FTDI chip and the debug interface is fully powered from the host. We have USB-C for power delivery, and another USB-C which I have going to a hub, which you can see on the other camera view, but I'll show you that later, and Ethernet, of course. So I'm connecting to these over the network. This one here is MIPI. This is a MIPI CSI. I've 3D printed a little case for this, but that's the mini SAS to CSI board from NXP. So it's basically just an adapter board that connects the MIPI CSI to a camera. It's not a particularly great camera, but it's sort of targeted at basic industrial processes. And then they use, excuse me, for HDMI, they've got another separate board that does MIPI DSI to HDMI chip there. And so we didn't route that or anything. We're just using the off-the-shelf boards for this. I'll put this one aside. Now this is the original NXP EVK, just for comparison. I have put some heat sinks on the flash, SOC, and DDR. Just they do get toasty when I'm doing 3D graphics and stuff on it, but this is just to show like everything is laid out as far as the connectors, module shape, and all of that, so that we can do testing across different boards. Shoot, it's 10 o'clock already. I've got to get my skates on. And the other thing was, and this is evidence that the board revision was different, even though like they've got stickers all over it saying that. But if you look at the component placements on these, everything's sort of laid out like a human would do it, obviously, because a human did do it. But they had even a different Ethernet connector with the tab down on this one, and the variant I ended up working with had the tab up. Okay, this one's power. This one goes to the hub. Why does my monitor keep going off? Just gotta check on YouTube real quick to make sure we're still casting. And there's some questions in. Where can you? Oh, yeah. Where can you download the Altium files for this PCB? From Dimitri L3G. That would be the Quilter blog site for Project Speedrun. I'll just give me 1 second and I'll share with you the link. Quilter.ai. and I'll post that in the chat. So this is the link here. Excuse me. All right. So let's get these GSI, CSI ports connected. Sorry. The other thing of note is that we had no, in order to give Quilter the best chance of completion, we ended up not including pretty much all of the test points. So that does make probing a new board a little bit difficult if we needed to probe it. Okay, so this is all plugged in and ready to go. I'll just power up. And if we switch to my terminal here, first of all, let me just check which, just looking on device manager, which ports this came up as. It's COM3 and 4, so let's keep that. Let's reconnect that. And that's somehow let's hit the reset. Man, it's hard to press these tiny, teeny little switches. Probably because that's the infrared port, not the switch. There it is. So that's booting. It's loading the factory board support package. It should boot with Wayland Desktop. In any case, I can just log in here as root, and then in the EVK, there's a bunch of different tests we could do, but I like some of the most basic ones, like ls USB is just the Linux command for scanning USB port, and so it shows all the things plugged into the USB hub that we have on there. So USB is working. ifconfig shows Ethernet's working. We have an IP address. So you get the picture. I don't know why, but I should be seeing on my little display that's attached to this board. Maybe I'll restart my video capture device. It's not the most expensive HDMI capture device. So we should be seeing, I've got a little cursor there. I can see a tiny blinking cursor in the screen, but we don't have the desktop for some reason, probably because it wasn't enabled on boot on this particular, whatever's going on in this image. But this is all functioning. Okay, so here we have board set number 10 from Sierra in its anti-static packaging. So let's do a close-up again here. So you can see this matches the layout I was just showing you in LTM 365 there. And let's see if I can make it more close-up focus on this. That's more fuzzy. Let's see, there it is. So you can see just in the close-up view, look at those power polygon pores, clearly done by automation, AI, not done by a human. They were modified and cleaned up a bit by me, but essentially all of that power delivery network, some of the stuff I did in cleanup was on the inner layers. A lot of these polygons getting the different power rails to the different chips, they were all originated like and mainly done by Quilter, not by me. So we look at this, and there's something else I just remembered too. I forgot to do a proper assembly variant on this. So I'll power off the NXP board real quick. Where's my Phillips? It's in the drawer. Just need a screwdriver real quick. No, it's not in the drawer. I'll put that. Oh, here it is. Grab a couple other small screwdrivers while I'm at it, just to be prepared. Okay. So I'll just remove the factory NXP board. And these UFL connectors. I know they're tiny and they solve the problem, but they're really difficult to work with. Okay. So here's the factory NXP board. And it's a bit difficult because using the black solder mask makes it harder to see or compare those PDN pores and things like that. But you can see a bunch in there. The stuff. What I wanted to point out though was these are strapping resistors in the design, as are these. They're like factory set jumpers. And there's a couple more, up around here. This R76, R47, and these ones down here, which basically enable or disable the possibility of booting from SD card, which made it difficult for me. I thought we had a problem with our SDIO interface. I thought that was the thing that didn't work when we first powered these up, but actually it's just because I forgot to make sure that those resistors, like in the factory board, they're not fitted. I forgot to make sure I duplicated that. And so we see those here. They're actually fitted. And those ones and these two up here. So to make sure that that functionality works, I will probably have to desolder those, but we may not have time for that today. Anyway, this is how it goes. Let's get that back in focus. We're putting NXP baseboard with our SOM. And that way I don't have to change the boot configuration settings on the jumpers either, just at least to get this to go. Now, these connectors are a bit tricky. Got to press down pretty hard to get it going, but okay, let's see what happens. We still have the same COM port and everything because I'm on that baseboard, so it's not re-enumerated that. So let's go back to this view. And I'll power this on again. So we've got power, but I'm not seeing any booting. And the reason for that is it's meant to boot off this eMMC flash. There's nothing in that flash. So the first thing we need to do here is run the NXP tool in a terminal to load the image onto that flash. So let's see, let's see, dev tools. I'm browsing my folders here. NXP. Yeah, this is the universal, they call it the Universal Update Utility, or UUU. So let's switch to my desktop view real quick. So on one side I have over on this side, I have the terminal. On this side I've got my PowerShell. Let's go to command because it's actually easier to use UUU from Windows Command Interpreter. And let's see, I want to do UUU, and we're going to do LF 612. Yeah, that's the one. That's the image I want. So that's waiting. Then what I have to do is put this board into download mode. This is where I need a magnifying glass. So we've got this one, download mode. We have one, zero, one, zero, and everything else is a don't care. Okay. So UUU is waiting. Now let's go. Excuse me. So on the board, I'm just going to hard reset it, power off, power on. And then switch back to the laptop view there. So as soon as we do that, we should, oh wait, it would help. It would definitely help if I actually plug the USB-C, because to do the firmware update, you do it over the USB-C peripheral port to the host machine. So I need a USB-C cable. Let's use this one to my host machine. I have a hub over here somewhere I can plug into. Waiting for a known USB device to appear. Now power on, there it goes. So over the serial debug terminal, we can see it's actually running on the client side. It's doing the download. So right now we're just programming the factory flash into this eMMC chip on our 10th SOM. So that's a good start. When you can program the flash, that's a very good starting point. And unfortunately, I can't make that go faster. So while we're waiting for that to boot, to download and reset, let me head back over to YouTube and see if there's any other questions. Yes, good question. What about EMC compliance? We didn't do any formal EMC testing on this. The point of this was to show that we could build a computer, use Quilter to design a computer, and that it would actually boot and run Linux and do graphics and all that stuff. Because if you get that far, you've already achieved like a lot. If you get that far, you've solved a lot of problems. You've solved things like DDR connection, high-speed SPI bus, a lot of things. But I'll refer back to, this is also why Quilter by default will choose a layer stack. Now you can tell it to use your own layer stack, but we have a library of layer stacks that are known good built into it with unbroken ground planes. So yeah, we may use more layers than what a human could possibly do the design in. And that's because we're introducing unbroken ground planes to circumvent EMC, EMI problems. So all of those surface traces are microstrip lines. They have unbroken ground under them, but there was one, or maybe there were two specific bits in the DDR interface. We had Signal Edge Solutions. Big shout out to Signal Edge and Ben Dannon and his crew. We actually had them take the design files as we had sent to production and do signal and power integrity analysis on them. There was one DDR bit, I think it was data bit 13 on the DDR interface, that was marginal with its I because the trace crossed over where there were two vias side by side with it, and the plane underneath had a gap between the vias. And so we were concerned that that would cause a problem for that DB13, but as it turns out, it's working. So, and that's also why I brought this beautiful Rodian Schwartz scope here and the near field probes, because I wanted to see if I could pick up any radiation from that with a near field probe. So we'll do that soon. Sorry, you're staring at my YouTube control there. We should be looking at this. So we're at 55%. While we're doing that, we could actually, because look, it's not just programming the eMMC flash, it is using and buffering the DDR to do this. So I'll get the near field probe in here and we'll have a look at what's on the scope. Now I want to look at the scope screen too, just so I know what's happening. So here I have channel 1. Actually, first let me show you on the Brio camera. So here we have channel 1 coming in. I've already set this to be using channel 1, and I have This is just a cheap, janky PCB near-field probe, but it does actually pick up, it's the medium-sized one. It is picking up some reasonable RF sort of stuff around, and you can see when I'm talking, it's actually it's probably picking up transmission from my wireless microphone. I don't know really if that's the case, but it's reasonably sensitive. And let's have a look here. So I'm bringing this probe over here. The area of concern was right in between these two chips. This device here is LPDDR4. This is the SoC, the IMX8M Mini. This is the eMMC flash that we're programming right now. So let's go back to the scope screen as I bring that probe as much as possible right over there. There is some noise coming out of that. Again, I'll switch to the top-down camera so you can see where I'm just over that area right between those devices. So if I trigger on that high level, there's a lot of noise on that. I could do some noise rejection and stuff. But yeah, I'm picking up DDR interface stuff. And if I go away from there, there's less. There's a lot of noise around the PMIC, but that's to be expected. It's basically 10 switching regulators in one chip, switching converters. But you can see there's definitely a specific, if you look at the FFT on the scope underneath, the noise is pretty low. Like it's showing mostly below 50 dBm on this near field probe. Excuse me. But it's not a bad, like, I think this would pass a regular EMC test for radiation. Now, if I go to the eMMC flash chip and put this over that, yeah, we're not actually seeing a lot. Maybe it's the clock I want to look at. So this looks quite different than the running board that I was showing before. But you'll see that there is definitely some regular spikes in the spectrum down there. And there's some big spikes that you see blapping like that. I believe what we're observing is the signals going from the SOC to the flash to program a page or a chunk of bytes. So while that's going, let's head back to here. It looks like we may have finished programming. Let me switch back to this. Yes, so that's done. So the programming of the flash is complete. So what we do now, of course, is we change the jumpers. I'll turn it off. I'll set the jumpers to boot from eMMC. So that's 0, 1, 1, 0, 1, 1, 0, 0, 0, 1 on the top switch, and on the bottom switch it's 0, 0, 0, 1, 0, 1, 0, 1, 0, 0. Yep, so that's all correct. So what we should observe in the terminal now, if I boot this, it should just start. And there it is. Now I'll hit pause on that. Actually, let's do that again. I'll reset it and I'll hit pause on that. So we're in U-boot. So what you see here is it begins U-boot. Like even before, here we are, U-boot. It shows. So start DRAM init. So this is that part of the boot sequence where even before U-boot has started booting the lowest level drivers in support of loading the Linux kernel, it's already done the link training and it's finding that it can use the DRAM at the full rate of 3,000 megatransfers a second, which is the fastest that this chip variant supports. And it says DDR5 calibration done. So that's the link training I was talking about. DDR mux config done. And then it says trying to boot from MMC2, which is the onboard eMMC flash chip. And then it starts getting, it's loading the U-boot environment from the flash to start booting Linux there. So I can carry on booting, just type boot. And then hopefully you can see we've got the Linux penguins coming up. We've got the BSP comes up with the Yocto splash screen. And then we've got the Western desktop showing on this little screen here. I can show you, let's see. I can show you direct to the stream. This should be giving us the video capture of that. I don't know why is that not? There it is. Okay, so this is the actual HDMI capture of the desktop. Okay, next question. Do the other USB peripherals work? They should be, but I haven't plugged them in yet. So I'm going to unplug my host USB, which we used for flashing, and plug back in the USB hub that has the keyboard and other stuff connected to it. And look at that, I've got a mouse. It's hard to see on the screen, but I can prove it to you by opening some of the demo applications. And you'll see the mouse cursor now because it's like a little fly that you can swat. Okay, let's see. So this is good. Not all of these demos are for the IMX8M mini chip, but this one, Bloom, works beautifully, should work beautifully. There it is. Wow, it's got the menu is like scaled like crazy. This is full 3D acceleration from the IMX8M mini chip. So that's functioning on the Quilter SOM on the NXP baseboard. Now, in the interest of time, because we've already been at this for an hour and a half and I'm supposed to finish, but I'm happy just to carry on if you guys are. First of all, that being the case, definitely let me know in the comments. Dimitri, you had another few questions. Does Quilter care about crosstalk? Yes. Does it care about EMC? Yes. And this is why we have different, constraints and what we call circuit comprehensions that go into it. You can specify clearances that are needed for different things. Basically, fundamentally, the minimum clearance in Quilter is the manufacturing clearance. And how is it implemented? It's basically, Quilter is PCB design as a service. As it is right now, you upload boards into Quilter. You go to quilter.ai, you set up an account. You upload your boards and schematic files to Quilter. No one else can see them. Only our model sees them. and you set your constraints. You approve the layer stack that it wants to try and use, and then you press go and you come back sometime later, maybe a day later, maybe a few hours later. It depends on the complexity of the board. Quilter goes away, places and routes it, and then you come back to a few candidates, and really the best one is presented to you. So then at that point, you can say, let me look at some other options. But at that point, you download your files again as completed files, and then you do cleanup and get them ready for production back in the CAD tool in which you started, which could be Altium, could be KiCad, could be Cadence, or could be Mentor Expedition. Those are the ones we support now, and there will be more in future. Okay, so I'm satisfied that all that's working pretty darn good and no blue smoke came out. So what I'm actually going to do at this point is shut this down again. I'll do that from the terminal. Let's go back to that program group. So back here in the terminal, just go to root. So I'm logged in, but I'm going to do shutdown. I'll do a soft power down, shutdown now. And that turns it off. Soft power off. Okay, but then I'll flip the switch. Okay, let's get that out of the way for now. Okay, so now I'll disconnect our SOM from the factory baseboard. This is an anti-static or static dissipative workbench, by the way, just so you know. So don't get all OCD on me for handling boards on what looks like a white workbench. It is a proper static dissipative workstation. Okay, so fresh from the factory, the last baseboard. And I'll do a close-up on this one as well, just so you can see how different it is. I'll unplug all this stuff from the factory baseboard. And let's go back to that close-up boards view. I'll unplug all of that. So again, this is there. Why does that monitor keep disappearing? Okay, this is the factory baseboard. You see it's got the NXP logo. It's got those little switches that were no longer available in supply chain. I also didn't fit the IRDA interface, so I don't have a way of testing that because those were also not available in supply chain. And notice we have the Ethernet, gig Ethernet jack is tabbed down on this one. On the back, we've got this audio expansion header. It's really just like another GPIO, really. All the components are laid out like in rows and columns, nice and neat. We have PCIe and SD card. On the Quilter board, which has no standoffs on it, so it's going to be a bit wonky, but you can see the placement is very different, and that's because it was placed by AI. But note that all those caps and inductors for the switching regulators and so on, they're all placed very close to each other because Quilter understands what a DC to DC converter is, and the placement model, placement AI engine, does its best to optimally place these things. Again, it doesn't look like a human did it. It's not meant to look like a human did it because a human didn't do it. But we have pre-placed all the same connectors so that everything's compatible for testing and for mechanical design. So we've got the SD card, PCIe. On this side, we've got the same like GPIO header. These switches are the replacement I found from C&K, which again, I had a mistake in the footprint. So these are currently wired such that they are shorting out the on-off and reset. So just to prove it to you, that's going to prevent this thing from even powering on. But again, before we plug it all together, I'm going to plug in the NXP SOM board to our baseboard. That goes together pretty good. Got to make sure those connectors are seated well. And you'll see our Ethernet jack was a different part number from the same manufacturer. Tab up. I also had to change the audio connector because the audio connector, the audio line out jack that's used here on the NXP factory board is also not available in supply chain at the time of production. So I had to change that and update that footprint as well for the audio output. Nevertheless, first thing, let's get some focus on that. First thing is debug port. So if we look at that, and I'll try to reconnect, it may not work, probably because it's, if I look at it, is it loaded as a new debug COM port? No, it is the same. Okay. So in device manager, let's see, I'll show you device manager real quick. So in device manager, you can see here, it's showing up still as USB serial ports to COM3 and COM4. So that's comforting. At least the debug, at least the USB to the FTDI chip part is working. That's always a good thing. Go back to this view here with the terminal and my hardware. It's Ethernet. This is the power input. And here we have the peripheral. So it's just all in, whole hog. So this is the Quilter baseboard. The Quilter baseboard with the NXP factory SOM. And I power on and I get one power LED blink there and then nothing. And again, that is caused by these switches shorting out the soft on, off, and reset to ground. So I've got to remove those. So to that end, I have a fancy soldering iron here. I've never used this one yet. It's brand new. I should probably unplug all of this while I'm soldering and desoldering things as well, so I don't short anything out. So, okay. This should be set to 320. It's on. I'll actually bump it up to 380 and turn it on. I have some extra solder. I think it knows when I'm holding it. But I'm done with that one. That's it. Channel 1. This thing's so fancy. This should be on. It knows what the tip is. Just to be sure I know I'm talking to the right channel. Yes, I can see the channel color. Oh man, it's going to make me wait 2 minutes for it to heat up. You kidding? Okay, while we're waiting for that, so you can see me this way. While we're waiting for that, let me check for comments. Love the factory, awesome. Yes, I appreciate that. Okay, well, no more comments just right now. Either I'm really boring or no, I don't think this is boring at all. I love this stuff. Bringing up a new board can be like jumping out of an airplane with a parachute. Okay, now we have heat. So what I have to do, and this is slightly risky, but I've got to dump a whole lot of solder on these things and knock them off the board. Fortunately, these are soft on-off switches and there's pull up on them. And so they're not actually needed for this board to actually work. So there's that one off. And that one off. Put that back in its holder. Oh, hot, hot, hot. Okay. So now let's plug this all back in. Power, peripherals, debug. Let's go camera. And HDMI. Okay, what's the next thing? We haven't set any of those dip switch settings yet. So right now they're in no man's land. So I have to, let me get zoomed in if I can there. Oh, that's probably as close as I can get to that. Right, but I have to take the Mylar film off of these. Or I guess it's polyimide. And set this to boot from eMMC because we know the eMMC on this board is programmed with the BSP and is functioning. So it's going to be 0, 0, 1, 1 0 1 1 0 1, and then this one's 0 0 0 1 0 1 0 1 0 0. So this ought to give us a boot to the eMMC flash. So let me reconnect my terminal here to COM3. Go back to this view. So I've got COM3 terminal here and the board. And we power on, and there it goes. That's a thing of beauty. And then you can see on the display over here, we've got the NXP logo shows up. Linux penguins. So, and here we are to the Western desktop. So this one's functioning. So this is the NXP factory board with our baseboard. Now I'm just going to be brutal here and not do a soft shutdown. I'll just turn it off because the final step is, of course, the Speedrun computer. Speedrun SOM, Speedrun baseboard. Is that seated well? I hope so. Okay, so this is the moment of truth. Well, I guess we've already had a few moments of truth, but this is the moment of truth. Let's go back here. And we power on. And remember last time we programmed this flash with the factory BSP. And there it goes, it's booting. And again, I think I just missed it here, but we should have the desktop. There's the Linux penguins. All right, let's run that demo again. Go point, and this time let's do something different. Let's do map image refraction. That's a cool one. So this is using the GLES and hardware acceleration on that GPU. So I'm going to let that run for a bit because I'm going to see if I can get my thermal camera going. In this case, so we can log in here. And while that's running too on the terminal, I'll leave that running for a bit. Let's go to this view here. On the terminal here, I'm going to do some tests. Let's put that near field probe back over the flash. You can see there's a lot more. This is radiated EMI from either the clock chip or the eMMC flash. I'm pretty sure it's the eMMC flash because this doesn't do it when we're not running from flash. Let's see if I can get my Flare app running. Meanwhile, let's have a look at this LS PCI. So it sees that there's a PCIe bridge. I haven't plugged anything into the board on that. I do have a little PCIe peripheral. Just a second here. Here it is. So we can test that. This is basically an additional Ethernet interface. A couple of these actually. So if I plug this into the PCIe port, hopefully it can cope with me hot plugging it, and I hold that there. Now let's go back to the terminal and do that LS PCI again. No, I guess I have to reboot for it to enumerate the device. LS USB gives us the list of all the USB peripherals plugged in, so that's working fine. IF config, Ethernet's fine. I've got my IP address there. So what I could do now is start a new session in the terminal. So that's what I'm going to do. And I'll make it an SSH session, and I'll connect to that by IP address. So 192.168.128.119. And there I am with the login prompt, but this is over Ethernet by SSH. So I'll log in as root. The default factory image has no security at all. You just log in as root with no password. And all the while, we're still doing, 3D graphics acceleration and so on. So here I am in a SSH session. And if I recall correctly, let's go back here. So we're in, I love this terminal program because it has so much cool integration. If I go into, I think it's opt. Yeah, G2D, there's all the GoPoint apps and samples. Those programs are actually stored in here. But if I go to IMX GPU SDK, and let's see. I must be in the wrong spot because I vaguely recall there being unit tests somewhere. CD, IMX, MM. No, okay. Never mind. Haven't got time for fiddling around with all that right now. The last thing I want to do is do some thermal imaging of this thing. Okay. So wow, it's kind of toasty. And just to show you that, I'll bring this up here. I didn't have a way of transmitting this, so hopefully I can make this clear. But that sock is 79 degrees C, which is not crazy. It's not crazy. The PMIC is equally like hot to the touch. if I get closer to it, it gets a bit more accurate. It's like 84 degrees. So, and that temperature, so let's plug this to display better. Yeah. So yeah, 84 degrees, 84.5 degrees. So it's not crazy. I mean, NXP's datasheet doesn't say thou shalt heatsink this. But me personally, I don't like chips that get hot to my touch. So it's just me. But that is why I put heat sinks on the memory and the sock. And really, I didn't actually do the thermal analysis with the FLIR early on. I probably should have put a heatsink actually on the PMIC and just the sock, because the memories, they're not even, they're cool as a cucumber. And this is warm because we're doing that. We're running a full operating system, multiple threads, and we're using 3D GPU hardware acceleration for ray tracing all at once. So there it is, folks. There's probably a lot more tests I could walk through and do with this, but I've been going at this now for a while, since 9:30. So I can't imagine people would want to stay with me too much longer. But I appreciate you all for joining, and I hope this has been fun, informative, and cool to see. But this is real proof. This is arguably the first computer that can run a Linux distribution where it was designed and mainly placed by AI tools. So I want to say thank you again. Thank you everyone again for joining me, and I hope this has been fun. There's some other cool stuff I will do while I have this scope in my possession, and so you can come back for more, and I'll produce more content. And I won't do it all live because live can be difficult to keep it short. But you can definitely look forward to some more videos around all of this stuff. Small, short, interesting ones. And so definitely come back for more, and we look forward to seeing you again. Thank you.